Hey students, this is lesson 10.1. In this lesson, we're going to learn how to solve problems using the Pythagorean theorem and how to identify right triangles using the Pythagorean theorem. All right, go ahead and do this review, some important terms so that we can discuss the parts of a right triangle. All right, here it is, one of the most important geometric theorems. Pythagorean theorem: in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In symbolic terms, a squared plus b squared, c squared. Go ahead and do 8 and 9, and so you can try and understand what this means. Okay, so the sum of the squares in region A, which is the square on the leg, one of the legs, plus the sum of the squares in region B, which is the square on the other leg, is equal to the number of square units in the bigger region C, which is on the hypotenuse. All right. So Anita is tiling the backsplash of her kitchen with triangular pieces of tile. If the sides of the triangle are 3 and 7, how long is the triangle's hypotenuse? So I think what that means is she's tiling it like this. So these triangles have legs that are 3 and 7. I'll just draw one here. And what we want to know is how long is that side of the triangle C. So we're going to use Pythagorean's theorem: a squared plus b squared is equal to c squared. And we know that the a and the b are always the two sides that make up the right angle, the 7 and 3. So we can do 7 squared plus 3 squared, and it doesn't matter if you put 3 squared plus 7 squared equal to c squared. Then we're just going to simplify those. And we get 49 plus 9 is equal to c squared. And that's 58 is equal to c squared. And now to solve a square, a quadratic like this, we can just take the square root of both sides. And we don't need both of them. We just need the principal square root, which means a positive square root. If we want to leave our number like that so it's exact, we can. If we want to know about what that is, we'll use our calculator. And if we round that to the nearest tenth, we get about 7.6 inches. All right, go ahead, you try that. All right, in this problem, you might notice that one of the shorter sides is the length that we're trying to find, one of the legs of the right triangle, and we're given the hypotenuse. The Pythagorean theorem works the same: a squared plus b squared is equal to c squared. And as long as we identify that a and b are legs, we can substitute in the known parts. So we'll say that this is a squared plus b squared is equal to, we know that c is always the hypotenuse along this side, so we're going to substitute 25 there. And then we'll just simplify this. And we need to subtract 49 from both sides. And we get b squared equals 576. Then we want to find the principal square root of 576. And that equals 24. All right, go ahead, you try that. All right, another thing we could use Pythagorean's theorem for is to decide whether or not a triangle is a right triangle. If it has side lengths a, b, and c such that a squared plus b squared equals c squared, then the triangle is a right triangle with the hypotenuse being the length c. So if we do this, 12, 16, and 20 are the sides of the triangle. And if we see that 12 squared plus 16 squared is equal to 20 squared, then it is a right triangle. So what we're going to do is 12 squared plus 16 squared, and see if that's equal to 20 squared. I'll let you go ahead and do that and fill in your answers, and you can check back. All right, so which of these lengths could be the length side of a right triangle? Now, always the two shorter sides are going to be your legs, A and B, and the longer side has to be the hypotenuse. So, so in this first one here, we're going to do 5 squared plus 8 squared, and see if that is equal to 10 squared. Well, 5 squared is 25, and 64 and 10 squared is 100, and that's equal to 89, and that's false. So we're going to say no on that one. Okay, the next one, B, 9 squared plus 40 squared would have to equal 41 squared. And 9 squared is 81, 40 squared is 1600, 41 squared. We can use our binomial properties to help us do that. We can just do 40 plus 1 squared. That's 1600 plus 40 times 1 times 2 is 80. So 1680 plus 1 squared, which is 1681. And 81 plus 1600 is 1681, so that's true. So we're going to say yes on that one. I'm going to let you try the next two, and you can check back with your answer. Either of those were right triangles. And so go ahead and do this problem 3 here on your own. See if you can figure it out. Make sure that you identify the right parts of the triangle with the right numbers. All right, we're up to the lesson check. Go ahead and do that, and we'll talk about this next time we meet in class.